Detrending is very useful if we're doing time series analysis. For a variety of reasons, we'll discuss about the reasons why detrending is important in time series analysis. Well, let's first understand what is detrending. Well, detrending is about removing the trend from the time series data. Now, if you have some familiar with time series data, I'm sure you're familiar with what a trend is, right? In most cases, you will see that the time series data has some trend. So, what do you mean then that removing the trend? Well, in layman language, it refers to the change in the mean of a time series over time, right? That's what we call as trend. And if you remove that from the time series, then we call that as detrending. So for time series modeling, it's important to get rid of the trend. So how can we do that? Okay, first take an example. So to understand what is detrending. Okay, here is an example. So we have stock price in the y-axis and time in the x-axis. And as you can see, we see a linear trend, right? The mean is changing over time. The mean is increasing steadily. And what we can do to detrend the series is to fit a linear line. It's a linear fit, so linear line would fit that, and then the detrend values are basically calculated like this. You have yi, that means your stock price, and then the estimated value of the stock price using this linear fit. So you will get yd. Well, I'm just denoting yd as the stock price. So that is basically your detrended series. Okay, I'm going to take another example with real data, but you cannot always fit a linear line. Sometime the pattern will be different. You will see a changing mean. Sometime it would be increasing and then decreasing and so on. And for that kind of a series, you will have to use quadratic detrending or some sort of a polynomial detrending. Here is this example where you see that a straight line will not fit. If you straight a straight line, it will not fit the data. Okay, but the way you get your detrended values exactly same as the formula that I showed you in the previous slide. There is another popular detrending method which is called differencing. It's a very popular method in time series modeling. It's in fact part of the ARIMA modeling. It's very simple. It's basically subtracting the lag of the series from the series. So if yt is the series and yt minus 1 is the lag, then basically yt minus 1 is the first order differencing, and then you can go on doing that, right? You can have second order also and third order and so on. So that's about differencing. We'll take an example to see how we can do detrending in Python. Okay, so let's do detrending in Python. So first import the important library, pandas, yes, for importing the time series data, and then to plot the data I've imported matplotlib, and then I've imported the data. So this is how it look like. It has two macroeconomic variables, prices of the stock and the return of the stock. We'll be only using the prices of the stock, and it's a time series data, so it has got data for 12 months. Okay, so let's plot it first. I'm using matplotlib's to plot this time series, and as you see, there is initially there's a decreasing trend and there is an upward trend, right? Downward trend and then upward trend. So there is presence of trend. You cannot do time series analysis with such a data without taking out the trend from it. At least most of the theoretical models will not fit properly. I mean, will not be of use unless you take out the trend from it. I'm going to take out the linear trend from it, but it seems like the linear trend will not fit this data, because initially it goes down and then goes up, so it doesn't seem to be linear. It seems to be more of a polynomial trend, so you have to use polynomial detrend, but I'm using here the linear detrend. So from the SciPy package, SciPy signal, we are importing Detrend, and here we are creating a new time series variable called Detrend underscore prices by detrending the original time series variable, which is the prices. And then once it is done, I'm plotting the data again, and this is how it looks like. As you see, it is yeah, ideally what should happen is that once you detrend a time series, the value should be yeah, hovering around 0. That means sometime the values are above 0, sometime they're below 0, right? But here it seems that there is a trend, so it's still not properly detrended, right? The other methods can be used, like taking out the first difference, for example. Okay, that's what we discussed, right? So I'm going to try the taking out the first difference, or doing the first differencing. How we do that? Okay, I'm first creating an object from the series, and then I'm using the diff function. So if you use diff function, it gives you basically the first order differencing. That's what we have done, and then I'm plotting the data with first order differencing, and it seems that it works out better, right? That doesn't, you do not have a trend anymore, right? After you detrend it, here you can see, right? It's pretty much random around 0.